Hello and welcome to the Software Assurance Marketplace Virtual Town Meeting. Our topic today is Good Security Starts with Software Assurance. I'm Marcy McCarthy and I'm the CEO and President of T.E.N, and I will be your moderator today. We're excited to bring you this live event and expert presentations on strategies to drive software assurance within the organization. It is my pleasure to welcome our presenters. Professor Barton Miller is the Chief Scientist with the Software Assurance Marketplace. And in our first presentation, Professor Miller will, in his welcoming remarks, will share his views on the past and current challenges that are facing software developers today. Our second presenter is Dr. Pat Baer, Project Manager with the Software Assurance Marketplace. And Pat is going to share with us the vision of S.W.A.M.P, the core services, the future capabilities, as well as its benefits. And our third presenter today is Phil Aquilli. Phil is going to share his software assurance executive and developer insights. After the presentations, our experts will continue for a conversation in a live Q&A session. We will be recording today's session to provide on-demand recordings for your viewing and for your fellow colleagues. We also are offering CPE credits for today, and if you would like to submit on your behalf, or please email your certification number to Deb Jones at djones@ten-inc.com, and that email address is again djones@ten-inc.com. And we will be happy to pass on your information and get you your CPE credits. Our first speaker is on deck, and I'd like to welcome Professor Barton P. Miller, again, Chief Scientist with the Software Assurance Marketplace. Please take it away, Professor Miller.
Hello, everybody, and a cold good afternoon to all of you who are here in the Midwest with us or on the East Coast, and a sunny, warm good morning to those of you in the West Coast, and happy lunchtime for those taking a break from skiing in the mountain states. I'd like to tell you a little bit about some motivational issues dealing with software assurance. And, you know, given the list of speakers, given the list of attendees I've looked at, I might be preaching to the choir to some of you, but give you a little bit of history. You know, if memories are all I sang, I'd rather drive a truck, as you remember from Garden Party, so I'll try not to reflect too much on that. But I want to give you a little bit of context and history.
Webinars, maybe.
And so, so I will give a little background there and a little bit of motivation, and then turn over for the bulk of it to Pat and Phil, which I think will be quite interesting. Of course, I'll be around at the end for questions. So next slide, please. So weaknesses in code are nothing new. If you go back to the dark ages, and some of you may have enough gray hairs to remember Robert Morris Jr. releasing the first internet worm that shut down the entire internet. Actually, it shut down all 1,100 sites on the internet at the time. And this weakness in the code was a buffer that was overflowed because they weren't checking the limits on the buffer, and this was the primordial stack smashing attack. And so clearly our C arrays and buffers were a problem. In 1989, we introduced here at Wisconsin, my group introduced the idea of fuzz random testing. And next, please. And next slide. Okay, so I'm not sure we're seeing animations, but that's okay. I had some cute ones for you. Oh, here comes the first worm. So we introduced fuzz random testing, and the goal was to study the robustness of utilities on a wide variety of Unix platforms. It was pre-Linux at the time, and I can give you a lot more background on this, and we have stuff written about it. But the basic idea was we introduced fuzz random testing, unstructured black box testing. We tested a wide variety of Linux systems, Unix systems at the time. We studied a lot of Unix applications, system utilities, we were calling them, and we could crash a quarter to a third or more on every version of Unix we tested. we then went, what made this fuzz testing interesting and which set fuzz testing on its feet was, we went and then took every single crash that we caused in this testing and debugged it and found the exact cause of every one on every platform. And this is what we do in academia. We're rather pedantic about things like that. And what we found by far the #1 source of errors was unchecked bounds on strings or arrays. So again, the same thing, surprising. Now, not to stay mired in the past, but looking at, if you look at the S.D.L.C. top 25 most dangerous software errors for this year or the year before, the year before, the year before, #3 on that list here in the 21st century with Buck Rogers looking over our shoulders is still unchecked bounds on strings or buffers in C programs. So so we really, we know a lot more. We have better coding ideas. We know a lot more about security from a research point of view, from a practical point of view, but still we're getting slammed by the same problems. Next slide, please. So in the meantime, the bad guys have been busy. So while we still have all these old things, we've introduced just a ton of new possibilities. We have injection attacks of every flavor, SQL command line, code injection, interpreter injection, and which are typically #1 and 2 in the SANS 25. Numeric attacks, those of you who look at it know that using integers can be dangerous. That's kind of a fun topic to look at. Exception handlers, race conditions, which for some reason people have called time of check, time of use, file path name manipulations, privilege escalations, sandbox escapes, virtual machine escapes, domain name spoofing, and a wide variety of web attacks across site scripting, forgeries, hijacking, open redirects, and you can put ... You name the ones you love. This is just a very small list. So the old problems are still here, and there are plenty of new problems for us to deal with. Next slide, please. So what I want to talk about right now is just one simple idea for a few slides before I pass the podium over. And basically, your first line of defense, as any of you have managed projects or work, is clean code. So the first thing is we need to teach our programmers how to write code with security in mind. And this is something that's severely lacking from curriculums out there, and there's many people that teach it. And my colleagues and I actually teach tutorials on secure programming techniques, and please feel free to either ask questions at the end or send me email if you want to know, because we teach these tutorials all over the world, and I'll be happy to talk with you more. So we need to kick programmers up a level and teach them not just software engineering, but secure program engineering. Now, even the best programmers make bugs, and I know none of you guys you folks on the webinar make these programs, but I'm sure you all know people that put bugs in their code. And so we need to give programmers the tools to help them try to find many of those kinds of bugs in their code, those weaknesses. So software assurance tools are our first line of defense. And we're talking about source code analysis tools, binary analysis tools, dynamic tools, tools for domain-specific, mobile web, etc. So these tools are absolutely crucial to keep programmers from tripping over many of the obvious things. These are the reminders, the extra checks. And now, when the S.W.A.M.P comes in, is let's say one of our key goals is to make these tools easy to run. So we think the S.W.A.M.P is a key asset for that. And I'll give you a little more background of that as we go along. Next slide, please. Now, one of the key things that you need to do to make these tools effective, and whether you're running in the S.W.A.M.P or anywhere else, is run the tools early and run them often. And let me give you an example, then I'll tie it back into tools. If you've ever taken an existing code base that has not been compiled with a high-level compiler warnings, and compilers have all these, besides syntax errors, can give you all these warning messages, and some of these modern compilers are very sophisticated. If you turn it up to a very high level of warning, you can get a lot of the problems that even some of the assessment tools catch are caught by compilers nowadays. If you take an existing code base for which you have not turned on warnings and just turn them on one day, you get screenful after screenful after screenful, literally tens or hundreds of thousands of messages like this on the screen here, which is an overwhelming amount of information and overwhelming number of tasks for a programmer to handle. And so the programmer is then overloaded and can't, it doesn't know what to do. So if you run your level of warnings from day one and keep your code clean, then you amortize it over the whole cost of developing the project. It's trivial to do. Similarly, these assessment tools are like a natural extension of the compiler warnings. They're the ones that soup it up to the next major level. And you've got to run these tools from day one and keep them running on every update. Next slide, please. So the S.W.A.M.P is the facility to help you run these tools early and often. We provide automation that makes it easy to apply a tool to a new software package. Very little effort for that. It allows you to get feedback on each code update, each commit. So it basically provides you the automation to get that. It provides the raw resources you need, storage and computation, to run these many tools over your software packages. So you can be constantly getting this result over a wide variety of packages and platforms, the smarts to combine the results in an intelligent way, and the ability to track progress over time and trends, so across tools, across packages, across tool versions, across packages versions. So there's a lot of things going on here that get taken care of in a single environment. You don't have to do. Next slide, please. So we look at the S.W.A.M.P as a resource for both the novice and the expert. The novice will be able to start using assurance tools with almost no effort or preparation. As long as they have the management the instructions from their manager to say you must commit clean code that doesn't have warnings or weaknesses present in it, the code will stay in stable condition. And not only that, they get the feedback from the tools, and that's a teaching process. So not only are they producing clean code, but they're learning to become better programmers in the process of doing this. This is a very key point here. Now the expert gets to do all the familiar tasks that they know and love, but they do it with less effort. Running the tools is easier, tracking results is easier, understanding the behavior, how well the tools are doing, understanding how well their source code base is doing becomes easier. So there's something here for both of those. Okay, so hopefully that pep talk got things started. I've run a little bit over my time. Next slide. So now I'll turn this over to Pat, who will tell you some things about the S.W.A.M.P itself, and then we'll get to hear from Phil about the view from the executive point of view. Thank you all.
Hey, good afternoon. I'm Patrick Beyer. I'm the project manager here for the Software Assurance Marketplace at the Mortgage Institute for Research. I'm going to talk to you a little bit about our vision of the S.W.A.M.P, some of the ways ahead that we're looking at, and how it's going to really apply to you. Next slide, please. Okay, basically the S.W.A.M.P is a $23 million project being led by the Mortgage Institute for Research, where we have a state-of-the-art secure hosting facility. Next slide, please. Okay, so what is the S.W.A.M.P? The Software Assurance Marketplace is, next slide, 5-year, $23 million grant. Next slide, please. Funded by the Department of Homeland Security, Science and Technology Directorate. Next slide. The goal is to build a facility where open source software can be tested for vulnerabilities, basically for free, open to anyone to use. Next. And really also to enable software researchers a place where they can do research in new assurance tools. Okay, next slide. This is our team profile. We are a joint effort of 4 research institutes. The Mortgage Institute for Research, we're a private nonprofit affiliated with the University of Wisconsin. We also have the University of Wisconsin, from which Dr. Miller is from. Also, we have a team from the University of Illinois Urbana-Champaign, which is doing our identity access management. And we also have the team from the Indiana University, which is doing our cybersecurity for us. So we have quite a large team across multiple institutes putting the SWA.M.P together to make sure it's the best SWA.M.P we can make. Okay, next slide, please. So here's the problem. Why have the SWA.M.P? Basically, there was an increased use of open source software and product development. I'm sure you all know this. Next slide, please. And this is why we use open source software. High reliability, generally peer review, low cost, costs you nothing, and does speed up the development cycle. Why reinvent the wheel when somebody's already done it, probably done a very good job at it. Next. And here's some of the concerns, though, that come with the use of open source. Unverified code, unknown source, and also there may be hidden vulnerabilities because you don't know who wrote the code. You don't know if they're a good person or a bad person. Okay, next slide. So basically the solution now is to test and analyze this open source software. Next, please. So there are many analysis tools available, right? But not one tool will find all the vulnerabilities you're looking for. Some tools are better at looking for some vulnerabilities than others. So it may require a dedicated test environment, a sandbox to test your code in. Next. And the cost time can be prohibitive for small developers to maintain the tools, maintain the sandbox, just additional overhead that they don't have the money or time for. Next. And once again, non-standard results from different tools. Each tool developer comes up with their own output, their own format, and it's up to the developer now to unscramble all that and see how it all ties together and get a unified report. Next. So we got to make a distinction between continuous integration versus continuous assurance. Next, please. Continuous integration, practice, and software engineering merging all developer working copies with a shared mainline several times a day. Of course, that's what it is. We're integrating all the different developers' code together. Next, please. Now, continuous assurance now takes that practice of continuous integration and now moves it to a new level where now we are incorporating the software assurance tools into this frequent build process. So now we are testing all of the software throughout the software development lifecycle to ensure that as we're developing our software, we are making sure we don't have hidden vulnerabilities, and we're not introducing new vulnerabilities every time we do an update. Next slide, please. Okay, the Continuous Assurance Laboratory, basically our computer room downstairs, is housed here in the Wisconsin Institutes for Discovery, which is the Mortgage Institute is housed in. Using Intel Xenon processors, we have about 700 plus cores, 5 terabytes of RAM. We are actually looking at increasing that quite a bit. And then we're actually up to 140 terabytes of hard disk space. And so we are capable basically of 12 teraflops at any one time with the current infrastructure we have. Okay, next slide. So once live, which is coming up here in 2 weeks, okay, we'll give users access to, next please, 5 assurance tools, 2 Java tools, 3 C, C++ tools, 100 packages out of NIST generally with known vulnerabilities to test new tools with. Next, support for 8 operating systems, generally Linux. We have 1 Windows operating system. We will be expanding that. We also will be expanding into the Macintosh, the iOS arena. Next. And so we're also going to provide a results viewer, which is really nice, as we talked before about the different tools giving different formats. Our intent is now to give you a single viewer so you can use multiple tools, import all the results into a single viewer, and now you can read results in a common format for each of the tools. Okay, next. So output pars to individual weaknesses with location in the code. Next. A single software package can be assessed now multiple times, and you can now see how the progression of your code has gone in relationship to vulnerabilities. Next, different tools. So use different tools, different tool versions. Next, different operating systems. Next. And multiple results will be merged, filtered, and sorted now into a common viewer interface. So now you can have a full understanding of how your code operates, different operating systems, different tool versions, and really get a good idea of how your code is developed and where it's going and how it is right now. Okay, next, please. Okay, so right now we're going to, at ILC, we should have a commercial viewing tool, which is Code DX done by Secure Decisions. It is another DHS software assurance grant performer. They are on the T.E.N grant performer. Next. Basically, software assurance visual analytics tool. And it's a very nice tool. We were fortunate that it was part of the DHS software assurance broad area announcement, and so we're able to take what they have and put it into the SW.A.M.P for users to use. Okay, next please. Okay, core services, next. Manage accounts, projects, and access control. So you'll be able to join the SW.A.M.P, okay? Be able to manage your own software packages and SW.A.P tools that you upload. Next, assess a software package. Next, and then view the assessment results and the dashboard. Okay, next. And conduct now continuous assurance, which is what we're all about. So load your code up, run it against the same tool, load up that you used on your previous version of your code, check the vulnerabilities. So you now, like I said, you're going to have a nice linear progression of how your code is developed and what vulnerabilities you have found and what you've mitigated. Okay, next slide. Now this is, we're talking future capabilities, and these are really broad brush strokes, of course. You know, there's a lot to do with static code development and mobile code assessment, bringing in dynamic testing tools and some of the provenance-related tools and exposing APIs. So this is really kind of our way ahead of what we're going to do. Our initial operating capability is really just going to be with static code assessment. We'll be constantly updating and improving that, but we're looking now probably around the summer of this year where we'll start talking about, actually we should have something innovated hopefully for mobile code assessment, which is one of the larger areas that, with all the new code out there, all the new phones, all the new OSs, that's something pretty big for everybody to really be testing their code, looking for vulnerabilities. Dynamic testing tools, which is a pretty big one, but one we're very interested in. We're looking at some provenance-related tools and once again exposing APIs for testing. Along with this, we are also not just stuck to this model. We're also adding some commercial tools we're looking at. We're constantly reviewing what's the best way for the SW.A.M.P to serve our user group out there, the people that need to use the SW.A.M.P to get their job done. And so we're also looking for input from the user community on maybe what's the next supported language, what's the next supported tool, what do we need now for operating systems. We're always looking for that kind of feedback to make sure that, once again, the community is getting the tools they need to do what they need. Okay, next slide, please. Okay, and that's all I have. I hope I didn't go through that too quick. So I want to thank you, and I'd like to welcome our next presenter, which is Phil Akatwili. I think I said it right. But thank you.
Hey, thanks a lot. Hey, so we'll bring it to the ounce of prevention slide. So, my name is Phil Akatwili. I've been the Chief Information Security Officer at numerous companies. I was formerly with VeriSign and at Dell, and Jeff was with Cox Communications. And so I bring you to this quote, "An ounce of prevention beats a pound of cure," from Ben Franklin, because it's such a great quote and philosophy on how to be efficient and bake in quality assurance from the get-go. I can't tell you how much wasted time, money, and headaches are saved operating using this approach. I've worked with thousands of developers, and what's interesting to me is, a lot of times the questions immediately pop up from dev leads or project managers that ask me, how much time are we going to be spending doing the security stuff? And many times I've just told people, just try using these software assurance technologies and you'll spend a few extra minutes, maybe hours. But the reality is, doing this type of checking early on, it's going to save you. And it's also helped educate a lot of developers in my time about concepts around balance checking and input validation and using secure libraries or secure include calls. And the reality is a lot of this is already out there. It's just a matter of knowing what you need in the front end, and then also taking a little bit of time out to remember to do some of the security testing. So we'll move on to the next slide. They'll talk more about this approach. So, what we're going to talk about here is, why software security is important, what your company's executives think is going on and expect, and why smarter software is the better way to go, and how to proceed, the path forward. So we'll move on to the next slide. So here, software is part of our everyday lives. What you all build makes life more convenient, but bad software has consequences. Some of the examples in here I think are pretty good, right? With transportation, there's controllers in your car that manages how your car works, also in aircraft. Same with power, that operate utilities, water, natural gas. And then in our banking and finance software through our ATM machines, point-of-sale systems, and it's a great opportunity now with all the Target and Neiman Marcus breach activity that's going on. It's all based around software. And so we put a lot of faith in unassured and incompetent software. And I think the quote there at the end of this slide is actually really smart. I mean, would you let a 7-year-old drive you around on the highway, pilot an aircraft, or balance your checkbook? Because we're at the point now where software is doing a lot of stuff to make our lives more convenient, putting a lot of faith in it, and how secure, how competent is that software today. And move on to the next slide. And so, like I said, we've poorly developed software for some time. A lot of money is spent annually on post-incident recovery. Insecure software represents a pervasive kinetic threat to critical infrastructure and our way of life. And so I'll stop here, but from an appetite of software, I think the world's changing. I've been brought to the executive to the executive boardroom and been asked about our security posture. And the reality is, many executives from CEOs to the top senior team to the board of directors, they expect that we're doing the right things. They expect that the job is getting done. And the reality is, there's a tension, right, especially in the development community and through our project management team to deliver on time, on budget. And the reality is that this healthy tension is overweight by this being able to deliver on time and on budget. And I think we're at the point now that the expectations from the executives are putting constraints both on security teams and also on development teams to do the right thing, to balance the deliverable with delivering safe, secure, reliable software. And so again, the prudent approach here is a proactive one. Studies have shown that security checking early on in the development lifecycle and in the integration of security throughout the development lifecycle saves a significant amount of time and money. So I'll move to the next slide. And so here, assured software is smartware. I mean, secure software, assured software is smartware. You have to think about this as not just this secure software, but as better quality software, free of defects and more reliable. In fact, in the companies that I've served over the last decade especially, what I've reinforced with them is that, the goal here is to release software that has a minimal amount of software defects. And a lot of times I take the word security out of that. In order for us to get into, UI, user acceptance testing, I would like to make sure that we minimize the amount of defects that we have. And if there are critical security defects, that's just encapsulated in the defect call-out list. Those need to be cleaned out and resolved before production launch. And so, I stop here because I think this is the future. But so much, again, is relying on the software that's built that we have to have some expectation in ourselves, maybe call it pride, but have the expectation ourselves that we're releasing software that has minimal defects. And move on to the next slide. And so, I thought this was good to include, but the statistics show that software, the software we build, we have room for improvement, right, from these defects. Where we may want to start is to ensure that we address the basics. I'm not sure how many of you are familiar with the Open Web Application Security Project, but they've developed over the last decade something called the OWASP Top 10. Top 10 security defects. And I think that's one awesome place to really start. If you look at the stat on this page, of the software applications in this study, 82% showed that they still had OWASP Top 10 defects. And so at least stopping those, I think, is going to help us build much smarter software. Next slide. And so, we include this because I want to reiterate what's been mentioned about S.W.A.M.P. The benefits of S.W.A.M.P. is, I've been at these other companies that we've spent hundreds of thousands, millions of dollars on software assurance technology. And what's really interesting and what caught my attention with the S.W.A.M.P. team was the fact that they were available for use. And, I can't imagine, startup companies, how they would do it, developers coming from universities. And I think this is a great opportunity to use the technology that the S.W.A.M.P. team has competitively to what some of the big enterprises are using, especially that they're spending millions of dollars and help grow this community to, again, build safer software for us in the future. So next slide. And so really the path forward is very simple. It's security testing early and often. That's the key. Again, one of the things that really blows my mind is when I go back and take a look at the history. I'm coming from the security perspective, and for me, 20 years ago, going back and doing penetration testing or vulnerability testing against pre-existing applications, and the struggles that we had with dev teams and our business to try to fix known security issues versus building it into the process, giving the tools to the software developers themselves, educating them on basic security practices to prevent very preventable security defects. It's such the better way to integrate security into the process. And so the path forward, again, it's security testing early and often. Next slide. So, kind of moving into the discussion phase, but I wanted to pose a few questions to you to help facilitate the Q&A. And so this slide here, some challenges that I have for you, right? So, is software security important to you and your company? If not, why not? Where have you been successful promoting and implementing application security? Where are you stuck? What's holding you back? Is it funding? Is it support? The need to deliver over security? And then how do we fix this? And so I'll turn it back to the moderators and have it open up for questions.
Thank you, Phil. Wonderful job, everybody. We've got several great questions that are coming in to us right now, and I'm going to go ahead and ask that our panelists and speakers be unmuted so that they can answer the questions accordingly. And I'm going to go ahead and start with our first question. And this might be more appropriate for Kevin Green. For those of you that don't know Kevin Green, he's the program manager for the Department of Homeland Security and Science and Technology Directorate for the Cybersecurity Division. Kevin, will DHS require its own software developers and the contractors who develop software for them, being you, the DHS, to run their code through S.W.A.M.P? Could you comment on that, Kevin?
Well, here, this is Pat. I'll comment. I don't believe Kevin's on this.
Not.
Our understanding right now is they're talking about opening it up to all the government contractors, government contractors and internal developers to use the S.W.A.M.P as part of their software assurance of open code that they're bringing in. So I don't think it's been mandated yet, but I do believe they're under discussions to have that done, not just with DHS, but with some other of the federal organizations.
All right, great. Thank you very much. Our next question is the SWAMP only available for open source projects or can be used for proprietary software development?
We basically welcome all sorts of projects. We have the privacy settings and enforcement mechanisms, so you can run your assessments on your code and choose to release the results or to not release the results. You can choose to make your software visible to the rest of the SWAMP or to make it not visible. So the answer is it's available to both open source projects and closed source projects.
All right, thank you very much. Our next question is, how can a developer gain access to the SWAMP in order to set up a project and begin using the open source tools? It would be good to have some instructions for developers prior to the go live date.
Pat, you want to take that?
Pat Fire again.
Pat, would you like to comment on that one?
Yes, I'll comment on this one. Right now, to gain access to the SWAMP, our main page is continuousassurance.org. And that's kind of our public site for the SWAMP. And on that, there will be a link for you to click to actually gain access into the SWAMP. So you can now request a user ID, and once you're approved, be able to open a project and use all of the capabilities of the SWAMP. On the main page of the continuousassurance.org will be the user's guide for the SWAMP, which will help to explain the particulars of how you get into the SWAMP, what is required, what information you're going to need, so that you will have that prior to actually entering into the SWAMP. We're in the final stages of getting the user manual done, but we will have it posted on the main site for our live date on the 3rd, so that all users can now download that, review it first, and then come into the SWAMP.
Thank you, Pat. And I just want to also make mention that the instructions and quick guide will be are being finalized now and will be available on February 3rd. So we can send out information on that as well to everyone that joined us today as a quick update when that is available to everybody. Sound good? All right. Our next question is about, let's see, I lost my sequence because I had an interesting comment come in. Regarding the slide on continuous integration, how does the SWAMP get inserted into the automatic build process?
Let me handle that. So
would someone like to comment on that one?
Yeah, this is Bart Miller. I'll take that one. Basically, the initial mechanism is as you basically upload your software to the SWAMP, and you ensure that it builds conventionally. Just make it's a new environment. You know, libraries may be different. All the basic things you find, and you make sure it builds, and just make sure it builds in our environment. If there are problems with the build, you can be able to interactively come in with a command shell and fix these things in a pretty conventional sort of way. Once you've done that, you're done. We have built the software in plumbing that we actually monitor the build, and we actually know exactly how the program was compiled, how it was linked, all the options, what code is visible, what code is being put into a single executable, and from there we build the scripts that run the various tools that we support. So once you bring your software into the SWAMP and make sure it compiles, you know, probably should compile off the bat, but there's always a few little loose ends that one has. Tools will automatically run with your code. We're in, as in the future, and this will not happen when we go live in February, but it will happen sometime in the coming year, we're going to be integrating into some IDE environments. And so the process of uploading the software and ensuring and trying the initial builds will be push buttons from environments, perhaps like Eclipse, like that. But for right now, you bring your software in, make sure it builds in a conventional way, and then the S.W.A.M.P takes it from there.
All right, wonderful. Thank you very much. This is another question that we have. Let's see. The next question is, what protections are there in place within the S.W.A.M.P to keep identified source code vulnerabilities private? Is our NIST controls, ISO 27000 series overall? Could someone comment on that?
Okay, I've got this one. This is Pat Fire. We've built in some very strong security inside the S.W.A.M.P to the point that our developers cannot see what you in a project are doing. With our cybersecurity team at Indiana, has really been key in keeping everybody's source code private. So when you load something up, your personal source code, and you want to test against our S.W.A.M.P tools, and you want to have the results come out, those are your results. The only thing that we would possibly get off of that are going to be not information on specific vulnerabilities found in your code, but generic information that we can use for metrics that will help future software assurance tools be developed. Your code is your code, your results are your results. They're not published unless you desire to publish them. We have some very strict privacy built into the S.W.A.M.P because we're very concerned about that your code is your code, and we don't need some bad character out there to be grabbing your assessment results and now know how to get it and break the code. So that's something, we're going to have something on the site talking about our cybersecurity and how you can be confident that your code is your code, and that'll be up there on the 3rd, so you can take a look at it and rest assured that we have your privacy is utmost important to us, because otherwise it makes the S.W.A.M.P useless.
So in addition to what Pat presented, we also we're at DHS sponsorship. We're undergoing a tiger teaming effort, and I don't have in front of me the exact particular standards which they're testing us against, but we're using teams selected by the by DHS to evaluate our security. In addition, we have a separate security team. That's the team led by Von Welch down at Indiana University, which is doing continuous evaluations of security. We also run, if you name just about every internal scanning tool, network tool, OS scanning tool, web scanning tool, we're constantly running internally and from the outside just about every tool that we can get our hands on, including some you might not have heard of, to do that. So we're beating the system up pretty thoroughly, and no system is perfect, but I think we're running a pretty high level of assurance.
Thank you very much. Our next question is, several elements of this presentation spoke of the impact of software assurance on the bottom line. Will the S.W.A.M.P be made available to commercial companies to use? And if so, will it be a free or paid service? For example, I know of a developer of medical applications who should be using this to secure their applications. Can they do that?
We're gonna open up this to all users. You know, if you're comfortable with your software living in the S.W.A.M.P and are happy with our mechanism for protecting it, we're going to host that. You know, longer term, and longer term means, you know, the 3 to 5 year window. We're going to have to look at the cost model for operating this, but in the medium term, we're certainly opening it up. There's an alternative that is also, the S.W.A.M.P itself will be a product. We're a bit a ways from that, but we're going to basically think of the S.W.A.M.P in a box that you could for your own use, download your own instance of the SWA.M.P and run your own internal version of it with all the automation and mechanisms that is applied there, and then you might contract with us for some kind of technical support in that. But that's a model that's a little bit down the road, and we haven't gotten all the details in that, but that's a place we know where we're going.
Yeah, this is Pat Byer. The intent of the SWA.M.P, once again, is to improve the software assurance of software. I mean, that's what we're about, and that's why it's free right now for everyone to come in and use, because it's being funded by the government. I mean, we are a public service at this point for software developers to improve their code.
Perfect. Thank you very much. On to our next question. Yesterday, a listener asked about whether functional extraction would be included in the SWA.M.P toolset. The reply was a general agreement in broadening the SWA.M.P offering. Would today's speakers be more specific in addressing the capability of KDM-based tools like those KDM and Analytics or HAFA systems?
Well, let me talk about that. You know, we actually have talked pretty regularly with the KDM folks about tools and also about data representations. And none of our current tools on the short list are doing dive down, deconstruct, building a database of code structures. That's just not on the short list of immediate capabilities that people need for assurance. But we're definitely actively gathering new tools, and we will, as demand comes up. Well, new tools will come in one of three ways. One is either we see a tool that we decide is very attractive for some reason. Two, we get a definite request for a capability or a tool, and if we evaluate that tool as reasonable, we will definitely bring it in. Or three, somebody who has a tool, like KDM, wants to work with us to bring that tool into the SWA.M.P. There's really nothing different about the structure of running a function extraction tool or any other kind of source code analysis tool. It's different from other source code analysis tools. The only thing that's different is it produces a fairly complex different set of objects, and we have to work and arrange a way of storing and naming those objects out there so other people can access them. So right now we've had no requests for tools that do that sort of stuff. That's not on our short list. And we've had nobody offer to say we want to bring our tool in right now. But we are very responsive to these kinds of things. So if this is on your short list, either because you want to provide such a tool or because you want to use such a tool, please contact us, and we're happy to move ahead with that.
All right, well, thank you. On to our next question. Regarding the slide on continuous integration, how does the SWA.M.P get inserted into the automatic build process? Great question.
Okay, so this is, I hope this is a question. I'm going to give a little bit of technical background, and we'll put together a white paper on this sometime in the next couple of months. And let me, so basically there are many ways of trying to apply a software tool, a software analysis tool, to a build process. The one way that everybody agrees upon that is the 100% effective way is go to the lowest common denominator. Monitor the OS, the operating system interface that triggers the compiler. And for those of you who are technical types, every time on a Linux you see an exec call to the compile phase, that's one of them. There's an equivalent on Windows. We have an equivalent on the Java and Maven environments and so on. There's a lowest level place where you can tap into the OS. You can watch for key events which you'll never miss a compile event. And when you see that compile event, you'll see every single detail, which libraries were used, which include files, so you'll know exactly how the code was compiled, which code was used, which was not, which options were used, etc. So we are interfacing at this key level and capturing that. and then we provide that in a generic format that you can then, with a little bit of configuration magic, turn that into a command to drive whatever new tool you want to drive that way. Let me say that this bit of what I like to call the plumbing that monitors this is all open source. And what you see is the very high-end commercial tools have built this, and they don't share it because it's their secret sauce. People who build smaller tools and research projects and smaller companies don't have the secret sauce. We want to raise the level of all these tools out there. So we're providing this infrastructure, this build monitoring infrastructure for both Java, C, and C++ as open source software. It's not out. We haven't yet put up a software products page on our website, but we're happy to share this on an individual basis now, and sometime in the next couple of months we'll start putting up our software products page, because every artifact that we build is open source. This is part of what your tax dollars are buying you from the good folks at THS, and so we'll be sharing this. So this is how it works, and it works very effectively. And if you are working on a tool and you want this, so your tool is of the same level of ease, whether it runs in the SWAMP or not, we're providing that source code for free.
Wonderful, thank you. Our next question, again, it's, let's see, tools like the SWAMP identify definitely a step in the right direction. Due to the cost of insecure code to the economy, for example, Target, the store, what can be done to remediate the current software? Is there a way to entice or force companies like Microsoft or Google, Android to go back and clean up their applications?
Well, let me answer that. And
We could debate all day on that one, but I'd love to hear your thoughts.
Oh, absolutely. I mean, Microsoft introduced their threat modeling methodology, and has a rather, and Microsoft has a huge code base, so they're just fighting a horrible battle, 50 million lines of code, plus or minus, for Windows. But they have a very strict code base. Google doesn't have an external assessment strategy, but it has very strict rules. And if you look at the number of holes that have been reported in things like Chrome, it's fairly small. What I'm really worried about more are companies that are not software companies per se, that they're not end-user software companies, but everybody else is building software that has an outward-facing surface to that, and then you end up with a very so I don't think the problem of the world is the Microsofts or the Googles. I think the problem is just everybody's writing software, and not everybody's got the expertise or team to do that. We have expertise here, and we're happy to share that and advise. You know, of course, we can't. You know, we're not going to take on everybody's problems or analyze, or we're not going to design people's code. But there's no clear good answer for that. And let me just give one little little aside, and you know, Phil might comment on this too. You know, if you go to one of your directors and say, I need to spend 10% of my division's budget on security, and let's say you get approval for that and you spend it, and you have no security events that year. At the end of the year, the thing you have to demonstrate for it that's quantitative is you made 10% less money. Now, of course, you didn't have any security events, but is that because nobody was attacking you? And you know, it's hard to compare. It's hard to say whether you didn't have any events unless your neighbor got broken into too, and you were the only one who didn't get broken into. So there's a constant ongoing economic discussion that's difficult. And it's a little frustrating this day and age that you do have to argue you need security, because Target is a perfect poster child for what happens if you're not really being careful.
Yeah, I will add to that as Phil. So maybe
perfect, Phil. I'd love for you to comment on this.
Yeah. So let's take a little bit of a different tack as well. I mean, so over the last year. You know, the U.S. government's been working on the U.S. cybersecurity framework. The National Institute of Standards and Technology has been driving it. And I think the reality is, and I agree that some of the big software providers like Microsoft, they found software security religion over a decade ago. I mean, Microsoft in 2002, Bill Gates issued a memo called the Trustworthy Computing Memo. You can Google it, and it's out there available. But long story short, ever since, Microsoft's main product has been going through software assurance, and just like it was previously mentioned, their code base is so big that they're dealing with scale, right? And so there are a lot of providers that are out there, and I think there's a lot of government pressure to make sure that numerous types of software manufacturers provide some level of software assurance that this is coming. It's going to come in some form or another, but I think the reality is that the U.S. cybersecurity framework is going to help provide some basic level of, bar of where people need to be, and then software security within that. That you all, as developers, are going to feel much more pressure to embed security practices in your development activities in the long term.
Thank you very much. That was a great answer to that. And to follow on to some of the things related to the government, there is a question specifically, could S.W.A.M.P identify the use in CDM and be part of the annual FISMA reporting that's required in Cyberscope?
In some ways, that's a little bit outside the scope of the S.W.A.M.P. I mean, we're a resource, we're an asset, and whether people choose to use us or are required to use us is something. It's something that we can't determine. That has to be determined outside of us. All I can say is if we get identified as an asset to satisfy a government requirement, we're ready to have those conversations. And then the question is, what's the scope of load that would bring up, and how do we handle it? But we're quite interested in having those discussions. But we're just, our job is to stand up the facility, make sure people understand it, socialize it in environments like this, and then take on the tasks as they come towards us.
I mean, I can add to that as well. I mean, a lot of
Perfect.
the
Thank you.
A lot of the CDM methodology really relies on operational security practices, not necessarily baked in application software assurance practices. I mean, I agree. I mean, if S.W.A.M.P is called out, there'd definitely be a resource for CDM. A majority of the tools, though, are again, they're based around soft patching, around kind of more the operational information technology security practices, not necessarily the development practices. I mean, I don't foresee software security being specifically called out inside of the CDM model today.
Thank you very much, Phil. This is a follow-on question to an earlier one regarding S.W.A.M.P security. And it's a little bit of an opinion, but I would love for the S.W.A.M.P folks to comment on it. More specifically, this will be an excellent source for bad actors to mine source code and vulnerabilities. It will probably relentlessly attack to get inside. I know you guys commented on the security around that, but I would like for you guys to comment on this person's opinion.
Well, first of all, given that a lot of the source code is open source, and every update, every resolved vulnerability, whatever is published instantly, in that aspect, we won't be a new target because this information is already out there. As far as whether we're a more attractive place to attack than a particular company's site or not, whether we're more vulnerable than a company's site, I think we're gonna have, I think, better than average security. I spend a lot of my time doing in-depth assessment of software and systems, and I know with enough funding and enough effort, almost any system can be accessed. So I don't have any strong answer for it. I don't think we're going to well, let me answer the way my grandmother would have answered it and said we should have such problems. If we reach the point where if we're starting to get very large quantities of corporate jewels in their private source code in the swamp, then we may reach the point where we become a more desirable target than someplace else to attack, and somebody may decide to throw larger assets at that. I think we're staffed and funded and have the experience, the operational experience, to put up a very strong level of defense, and I think DHS will keep parachuting in inspection teams to keep us at that level, using the government assets they have for evaluating environments. So, there's no real strong answer to that. There's no hard black and white answer. Anybody promises to never ever have a breach of any sort lives in a different world than I do. But I think we're pretty well equipped to keep things secure as any other facility.
Thank you very much. We have one last question, and it's a real simple yes or no, and I think it's going to be a yes from our SWAMP team. Folks would love to know if the SWAMP team will build an FAQ from the many questions and answers that we've had from the last 2 town meeting webinars. Would that be possible? We could happily help you make that happen as well from T.E.N.
Yes, we will do that.
I got a yes from the SWAMP team. Wonderful. I think there's a lot of great information shared over the last 2 days, and it only can, be better for everybody if they have an opportunity to read the FAQs. And other good news is we're going to have these 2 programs on demand recorded for future viewing. We will also have copies of the slides for you to download, so be on the lookout for an email from us on how to access that information. I do want to thank Barton and Pat and Phil for your excellent commentary and presentations today. As you've all pointed out, insecure software is a growing problem in need of fixing, and it sounds like you guys have a wonderful solution. We appreciate everyone being with us today, sharing your insights as well, and how to get ahead of the curve by taking a positive software assurance approach. Thank you for joining us today for this SWAMP virtual town meeting. And also, if you need your CPEs credited to your account, please do send an email in to Deb Jones, and that's DJONES at TEN-INC.com, and we will be very happy to go ahead and place that those credits in your account. Thank you again, everybody. We hope today's program was beneficial to you, and look forward to having you join us at a future program. Have a wonderful afternoon, and stay warm wherever you are, and if you don't go outside if it's too cold. Have a good one.